Hello students, this is lecture number 3 on limits. In this lecture, we are going to discuss some articles related to limits. So let us start with, let f and g be two real valued functions such that limit x goes to a, f of x is equal to L, and limit x goes to a, g of x equal to m. Then we have to prove that first limit x goes to a, alpha f at x is equal to alpha into L, where alpha is any real number. Second, limit x goes to a, f plus minus g at x is equal to L plus minus m. Third, limit x goes to a, mod of fx is equal to mod of L. Fourth, limit x goes to a, f into g at x is equal to L into m. And fifth is, limit x goes to a, f upon g at point x is equal to L upon m, provided m is not equal to 0. So we have to discuss these five parts one by one. So first we define how we can define sum of two functions. So given any x in domain D such that f plus g at x is equal to, is defined as f of x plus g of x, because it's a real valued function. So fx and gx are real valued. Second, given any alpha in R and x in domain D such that alpha f at x is defined as alpha of fx, alpha dot. So there is no need to write dot in between, because alpha is a real number and fx is also a real number, and we know that product of two real number is again a real number. So we write alpha fx. So we define sum of two function and scalar multiplication alpha into f at x, that is alpha f of x. Okay, so let us start to find the proof of first part. Limit x goes to a, alpha f at x is equal to alpha into L, alpha. So before writing the proof of this part, let us start with some rough estimation. So what we have to do, right? So this is some concept which we follow. What we have to do, we have to estimate first. We have to estimate alpha f x minus alpha f. So we start with this, right? When we write textbook proof, then it is different while discussing this this proof, right? So we first estimate alpha f at x minus alpha f, that is equal to, we define alpha f at x, that is equal to alpha f of x minus alpha L. So we can take alpha to be common, so it is fx minus L, and then we can use modulus property, mod alpha into fx minus L as mod alpha into mod fx minus L. Now we have to, it is given that limit x goes to a, fx is equal to L. It is already given. So this is given, limit x goes to a, f of x is equal to L, right? So now what we have to do, we have to estimate this. So हमें mod fx minus L को इस तरीके से चूज करना है, so that we are trying to find that this is less than epsilon. Our objective is to estimate mod alpha f at x minus alpha L to be less than epsilon. So हम क्या choose करेंगे mod fx minus L so that we get less than epsilon. So if we take mod fx minus L to be epsilon upon mod alpha, then mod alpha and mod alpha will cancel out, so we get epsilon. But there is some problem. What is that? If alpha is any real number, so if we take alpha to be 0, then we cannot divide, mod of 0 is 0, so we cannot divide by 0. So how we can remove, how we can make change so that this whole value to be less than epsilon. So हम क्या करेंगे इसमें? We add some constant, let it be 1. So now mod alpha plus 1, you take any real number, mod alpha plus 1 will never be equal to 0. And now we can write this as epsilon into mod alpha upon mod alpha plus 1. You can take any constant. You can take 2, you can take 3, you can take 1 by 2, 1 by 3, right? But we cannot take mod alpha minus 1. हम minus 1 नहीं लेंगे क्योंकि अल्फा 1 के लिए और अल्फा minus 1 के लिए दोनों केस में फिर से वो डिनोमिनेटर 0 बन सकता है. So we add something. So this, and we know that mod alpha upon mod alpha plus 1, this is less than 1. So we get this is less than epsilon into 1 because mod alpha upon mod alpha plus 1 is less than 1. This is less than 1. So this is equal to epsilon. So this is our strategy, how we start our proof. So now we write the textbook proof. So given limit x goes to a, f of x is equal to L, right? So this is given. So we can use the epsilon delta definition. So given any epsilon greater than 0, however small, there exists delta greater than 0. This delta depends upon epsilon such that mod of fx minus L is less than. Now we take this mod fx minus L to be less than, we choose this, that is less than epsilon upon mod alpha plus 1. Okay. For 0 less than mod x minus a less than delta. So where alpha belongs to R. Alpha is any real. Right? Okay. So now we have to estimate mod alpha f of x minus alpha f, mod of this, and we can write this as alpha f of x minus alpha L, and that is equal to mod, we can take alpha to be common, fx minus L, and we can write this mod alpha into mod fx minus L, because mod of a into b is equal to mod a mod b for all a b in R. So now this is less than epsilon upon mod alpha plus 1 for 0 less than mod x minus a less than delta. So this is equal to epsilon into mod alpha upon mod alpha plus 1, and which is less than epsilon into 1, that is equal to epsilon, because mod alpha upon mod alpha plus 1 is less than 1 for all alpha belongs to R. You can take any alpha such that mod alpha upon mod alpha plus 1 is less than 1. So this implies mod of alpha f at x minus alpha l is less than epsilon for 0 less than mod x minus a less than delta. This means, this implies that limit x goes to a, alpha f at x is equal to alpha f. So again, you can use pause, ERP, pause, revise, and then proceed. So second part is limit x goes to a, f plus, so we take f plus g at x, that is equal to L plus M. So again, we have to use the strategy. We have to estimate. So what is given? Given limit x goes to a, this is, we can say this is strategy. So strategy, limit x goes to a, f of x that is equal to L, and limit x goes to a, g of x is equal to f. So these are given, right? So we have to estimate. It means given epsilon greater than 0, there exists delta greater than 0, such that mod fx minus L is less than something for 0 less than mod x minus a less than delta, and mod gx minus L is less than something for 0 less than mod x minus a less than delta, right? So now we have to choose how we can take mod fx minus L to be less than some epsilon or some other number. So but how we can choose this? So we start with this. So we try to estimate this. So mod f plus g at x minus L plus m. We can write this. How we can define sum? So it is fx plus gx minus L minus m. Now limit x goes to fx goes to L, at x goes to a. So limit of fx equal to L. So we can combine fx and L. So fx minus L plus gx minus m. And we know that mod a plus b is less than equal to mod a plus 1. So we can write this as less than equal to fx minus L plus mod gx minus m. So because mod a plus b is less than equal to mod a plus mod b, you can, given any ab in R, you can take any ab belongs to R, mod a plus b is less than equal to mod a plus b. So now our goal is to prove this is less than, we have to prove that this is less than epsilon. तो उसके लिए हम क्या करेंगे? अब mod fx minus L और mod gx minus m हमें चूज करना, so that we get the value this is less than epsilon. So we take this to be less than epsilon by 2 plus gx minus m to be less than epsilon by 2 for 0 less than mod x minus a less than delta, and this is equal to epsilon. So we find out the result. Okay? So now we write the proof. So limit x goes to a, fx is equal to m, fx is equal to L, and limit x goes to a, gx is equal to m. This is given. So given any epsilon greater than 0, however small, there exists delta greater than 0. This delta depend upon epsilon such that mod of fx minus L is less than epsilon by 2 for 0 less than mod x minus a less than delta, and mod of even because we have two delta, two function, so it may be one function, one delta work for fx and another delta work for gx. So we cannot say this delta, same delta will work. So instead of writing taking one delta, we can say there exists delta 1 greater than 0 and delta 2 greater than 0. Both delta 1 and delta 2 depends upon epsilon such that mod fx minus L is less than epsilon for 0 less than mod x minus a less than delta 1, and mod gx minus m is less than epsilon. Even we can take this less than epsilon by 2. Okay? We have chosen mod fx minus L to be less than epsilon by 2 for 0 less than mod x minus a less than 10. इसलिए हमने पहले इसका एस्टिमेशन चेक कर लिया था कि mod fx minus L हमें क्या चूज करना है. So we find out that it is less than epsilon by 2. तो हमें यहाँ पर अब वही लिखना है. So now we have two delta. So we choose or we take delta is equal to minimum of delta 1 comma delta 2. Therefore, we get mod fx minus L to be less than epsilon by 2 for 0 less than mod x minus a less than delta, and mod gx minus m is less than epsilon by 2 for 0 less than mod x minus a less than delta. So this will work. Now what we have to do, we have to estimate mod f plus g at x minus L plus m. So this is equal to, now we define sum, that is fx plus gx minus L minus m, and that is equal to mod fx minus L plus gx minus m, which is less than equal to mod fx minus L plus mod gx minus m, because mod of a plus b given any a b in R such that mod a plus b is less than equal to mod a plus mod b. This is triangular inequality. Okay. So, and this is less than epsilon by 2 plus epsilon by 2 for 0 less than mod x minus a less than delta, and this is equal to epsilon. So we get the result. Okay. So this implies limit f goes to a, f plus g at x is equal to L plus m. So now you try second part, that is limit x goes to a, f minus g at x is equal to L minus m. Use the same concept to get that. Okay, third part is limit x goes to a mod of f of x is equal to mod of x. Right? Again, what we do, we use the same approach. We have to estimate first this, and it is given because given what is given that limit x goes to a fx equal to L. So for any epsilon greater than 0, there exists delta greater than 0 such that delta depends upon epsilon, so that mod fx minus L is less, and we have to choose this for 0 less than mod x minus a less than delta. So we have to find out what we take mod fx minus L so that we find out the result. So now what we have to estimate, हमें क्या estimate करना पड़ेगा? We have to estimate mod of mod fx minus mod L. हमें इसको estimate करना, and we know that this is less than equal to mod fx minus L, because given any a comma b belongs to R such that mod of mod a minus mod b is less than equal to mod a minus b. So we use this property, and mod fx minus L हमें इस लेफ्ट हैंड साइड को लेस देन एप्सिलॉन बनाना है, और हमारे पास क्या आया राइट हैंड साइड में mod fx minus L. So we take this to be less than epsilon. अगर मैं यहाँ पर इसको लेस देन एप्सिलॉन लेता हूँ, then again we get the same. Okay. So this part is all, so almost the proof is done. So now we write given limit x goes to a fx equal to L, given any, by definition, given any epsilon greater than 0, you can take however small epsilon you can take. So corresponding to that epsilon, you find out delta. There is this delta greater than 0. This delta depends upon epsilon such that mod fx minus L, we take this to be less than epsilon for 0 less than mod x minus a less than. ये कहाँ से पता लगा? ये यहाँ से हमने फाइंड आउट किया कि mod fx minus L हमें क्या लेना है. So we have to take mod fx minus L to be less than epsilon. So now we have to estimate mod of mod fx minus mod L, and this is less than equal to mod fx minus L by definition, by using this condition, and this is less than epsilon for 0 less than mod x minus a less than delta. So we get the result. So this implies that limit x goes to a mod fx is equal to mod. Now the next part is we have to prove that limit x goes to a f into g at x is equal to L into L. So what is given, we have to make the use of that. Limit x goes to a fx is equal to L, limit x goes to a g of x is equal to L, and it means for given epsilon greater than 0, there exists delta greater than 0 so that mod fx minus L is less than some number for 0 less than mod x minus a less than delta, and mod of gx minus m is less than some number for 0 less than mod x minus a less than delta. So we have to find कि हमें mod fx minus L क्या चूज करना है, mod gx minus m क्या होना चाहिए. So first we try to estimate the given. हमें क्या find out करना है, हमें estimate करना है mod f into g at x minus L, और हमारा रिजल्ट ये क्या होना चाहिए, लेस देन एप्सिलॉन होना चाहिए फॉर 0 less than mod x minus a लेस देन डेल्टा, ये हमारा ऑब्जेक्टिव। सो दिस वी हैव टू प्रूव। हम क्या करेंगे, वी स्टार्ट विद मॉड f into g at x minus l into f, that is equal to, we can write fx into gx minus l into f. Now here we use one trick, we add one number minus we add one number. वो हम कैसे ऐड और सब्ट्रैक्ट करेंगे, l into gx, we subtract l into gx and we add l into gx plus minus l into f. हमने यहाँ पर एक कॉन्सेप्ट यूज किया, वी ऐड समथिंग एंड सब्ट्रैक्ट समथिंग। अगर आपने gx फंक्शन ऐड करना है तो आप उसको इससे मल्टीप्लाई करोगे l से, f की लिमिट से, और अगर आप fx ऐड करते हो तो उसको m gx की लिमिट के साथ आपने मल्टीप्लाई करना। देखो यहाँ यू कैन सी l into gx, वी सब्ट्रैक्ट l into gx एंड ऐड l into gx। अगर gx आप ऐड करते हो, अगर आप fx ऐड करते हो तो आप m into fx सब्ट्रैक्ट करोगे और m into fx ऐड करोगे। सो फर्स्ट टर्म में हमारे पास क्या बन गया, यू कैन टेक gx टू बी कॉमन, तो ब्रैकेट में आ गया fx माइनस l प्लस सेकेंड में l यू कैन टेक कॉमन, तो आ गया gx माइनस m। सो यू by using the triangular inequality you can write this as mod of gx into fx minus l plus mod of l into gx minus m, and this is equal to mod gx into mod fx minus l plus mod l into mod gx minus m। तो यहाँ तो अगर आप ध्यान से देखोगे तो हमारे पास ये फर्स्ट टर्म जो आई है, यहाँ पर जो gx आया है ये mod gx है, ये कोई ये नंबर नहीं है, दिस इज अकॉर्डिंग टू, इफ यू टेक x equal to x1, then mod gx is some number. If you take x is equal to x2, then you get another number. So this is not fixed. So we have to use the condition of boundedness, right? Here function is gx is bounded function. It must be bounded. अगर ये bounded होगा, then only we can solve this. तो यहाँ एक कंडीशन हमारे पास आ गई कि हमें gx को bounded चूज करना पड़ेगा। बट यहाँ मॉड एल है, मॉड एल इज एनी नंबर, एनी फिक्स नंबर, सो ये तो चेंज नहीं होगा, तो यहाँ से ये प्रॉब्लम क्रिएट नहीं करेगा। लेकिन यहाँ जी हमारे पास आया है, सो वी हैव टू टेक वन मोर कंडीशन। क्या कंडीशन आ गई, वी हैव टू टेक जी टू बी बाउंडेड, जी टू बी बाउंडेड। तो अगर हम बाउंडेड लेते हैं तो बाउंडेड की कंडीशन से given any you can take any x in domain, there exists a positive number, let it be k greater than 0, such that for all x belongs to domain, mod of gx is less than equal to that number k। तो अगर हम k लेते हैं तो ये तो हमारा हो गया लेस देन k। नो हमें mod fx minus l क्या चूज करना पड़ेगा, we take this to be epsilon upon, अगर हम k लेते हैं तो we can now we can divide by k because k is greater than 0, so k is not equal to 0। but क्या हम epsilon by k से हमारा रिजल्ट हो जाएगा, so let us check now another second is mod gx minus m। ये हमने mod अल्फा के लिए देखा था कि अगर हम इसको epsilon upon mod l लेते हैं तो l may be 0, then it will create problem, so what we do, we take mod l plus 1। लेकिन ये टर्म के कैंसिल हुआ तो ये एप्सिलॉन आ गया, यहाँ से मॉड एल अपॉन मॉड एल प्लस 1, ये लेस देन 1 है तो ये एप्सिलॉन आ गया, एप्सिलॉन प्लस एप्सिलॉन 2 एप्सिलॉन, तो हमें लेस देन एप्सिलॉन बताना है। सो व्हाट वी डू, वी टेक एप्सिलॉन बाय 2, एप्सिलॉन बाय 2, नाउ होल रिजल्ट इज लेस देन एप्सिलॉन, वी गेट लेस देन एप्सिलॉन। नाउ द जॉब इज ओवर, ऑलमोस्ट वी राइट द ट्रूथ। ओके, सो लेट अस राइट। क्या इसमें क्या हमने देखा, अगर हम f मल्टीप्लाई करते अगर हम यहाँ पर ये जो फैक्टर है एल इंटू जी एक्स की जगह हम अगर m इंटू एफ एक्स ऐड करते और m इंटू एफ एक्स सब्ट्रैक्ट करते और m इंटू एफ एक्स ऐड करते तो हमें एफ एक्स को बाउंडेड लेना पड़ता, राइट। तो ये दोनों दोनों तरीके से रिजल्ट आप कर सकते हो। सो लेट अस राइट limit x goes to a fx is equal to, so given limit x goes to a f of x is equal to l and limit x goes to a gx equal to l. So first we take uh, let epsilon greater than 0 over small. So let g to be bounded, let g be a bounded function, bounded function. If g is bounded in a deleted neighborhood of a, how we can take uh, g to be bounded? Even with, we cannot take, we can say because limit x goes to a gx equal to m, it is given, then gx is bounded. So we can write here when without taking epsilon, since g is bounded, limit of gx equal to m, it is given, then by using theorem g be bounded in a deleted neighborhood of a. We have already discussed this theorem in lecture number 1. So we write by using using the theorem. So G is bounded. So it means there exists k greater than 0 such that mod of gx is less than equal to k for 0 less than mod x minus a less than delta 1. Let it be delta 1. So here we have to take let epsilon greater than 0 over small. There exists delta 1 greater than 0. This delta 1 depend upon epsilon such that even you can take this to be here. So mod x minus a is less than delta 1, right? So let this be our first condition. So we use this. Okay. Second, since limit x goes to a fx equal to l, so we can take, since epsilon greater than 0 is given, so there exists delta 2 greater than 0 and delta 3 greater than 0. Both delta 2 and delta 3 depends upon epsilon such that mod of fx minus l. Now fx minus l हमें क्या लेना है, क्या चूज करेंगे? So fx minus l we have to take epsilon upon 2k. Epsilon upon 2k. We see less than epsilon upon 2k for 0 less than mod x minus a less than delta 2 and mod of gx minus l m that is less than epsilon upon 2 to mod l plus 1 for 0 less than mod x minus a less than delta 3. So we have delta 1, delta 2 and delta 3. So let us take delta is equal to minimum of delta 1, delta 2, delta 3. So we get mod gx is less than equal to k for 0 less than mod x minus a less than delta, mod fx minus l less than epsilon upon 2k for same neighborhood and mod gx minus m less than epsilon upon 2 mod l plus 1 for same 0 less than mod x minus a less than delta. Now we start estimation. mod. Now mod f into g at x minus L into m. So we can write this as fx into gx minus L into m. So we use curly leaf. Curly leaf means we add something and we delete, subtract something. So we add minus L into gx and add, we subtract L into gx and add L into gx minus L into m. So that is equal to, you can take gx to be common. So fx minus L plus, you can take L to be common, gx minus M. And this is less than equal to mod gx into fx minus L plus mod L into gx minus M by using triangular inequality. And this is less than equal to, and this is equal to, this is equal to mod gx into mod fx minus L plus mod L into mod gx minus M, and this is less than k into epsilon upon 2k plus mod L into epsilon upon 2 mod L plus 1, and this is less than epsilon by 2 plus epsilon by 2, because mod L upon mod L plus 1 is less than 1, and that is equal to epsilon for 0 less than mod x minus a less than delta. So this implies limit x goes to a, f into g at point x is equal to L into M. So you can try. So again using PRP. So try limit x goes to a, f into g at point x is equal to L into M. But by estimating f into g at x minus Lm, so you add m into fx and you subtract m into fx and add m into fx minus L into M. Now you have to take f to be bounded, right? So you try this part, also try the fifth part. If you face any difficulty, then you can write your question in the chat box. We will discuss. Thank you. Have a nice day.